Question number 3. In the diagrams, the point A and C lie on the x-axis and y-axis respectively. Again, this is giving us some information regarding the question. If a point lies on the x-axis, then its y-coordinate is 0. So this has to be x comma some x comma 0. And if a coordinate lies on the y-axis, then its x coordinate has to be 0. So C is going to be 0 comma some y. Okay. So respectively, and the equation of AC is this. We're also given the equation of this line, so that's handy. That is 2y plus x is equals to 16. The point B has coordinate 2 comma 2. The perpendicular from B to AC meets AC at point X. So you're also given that this line is perpendicular to the given line. Okay, so and meet AC at point X, find the coordinates of X. Okay, so we need the coordinates of X. We already have equation of the line AC, which is 2y plus x is equals to 16. We can easily find equation of this line passing through Bx because we can find its slope and we also have a point 2 comma 2. So we can find its C as well. So we will be able to find equation of this line and then we're going to solve the red line and the blue line simultaneously either by using substitution method learned in grade 8 or the elimination method, and we'll be able to find the coordinates of x. Okay, so let's first talk about the gradient of the line AC, which is, this line is, let me mark it here, it's 2y plus x is equals to 16. Okay, so then what's the gradient of this line? First thing we're trying to find is gradient of AC. So let's rearrange the equation in the form of y is equals to mx plus c. We have 2y is equals to minus x plus 16. And then we have y equals minus half x plus 8. So the gradient of AC is negative half. Which means that the gradient of Bx will then be the negative reciprocal of that, which is 2. Okay. Now, the equation of Bx would be y equals mx plus c. To find c of the line Bx, we need a point on the line Bx, which we're given 2 comma 2. Let's use that. And that would give us y equals 2x minus 2 after simplification. Substitute x and y as 2 and 2 and get c is equals to minus 2. Okay, so now we have equation of the line Bx as well. This is y equals 2x minus 2. Now we're going to solve both the lines simultaneously and get their point of intersection. This point. If you extend the line Bx and look at the line AC, point X is the point of intersection. So to find point of intersection, you have to use simultaneous equations. Let me clear this. So now we have two equations. One is of AC, which was originally given in the question, 2y plus x is equals to 16. And the other one is Bx that we've just found. I'm rearranging Bx slightly. Y minus 2x is equals to minus 2. Now we need to solve these simultaneously. I'm using elimination method times 2. So we have 4y plus 2x equals 32. And then y minus 2x equals minus 2. That gives us 5y equals 30. That gives us y equals 6. If y is 6, we can substitute it in any values or in any one of the equations given, either this one and this one, and get x. I'm substituting it in the second equation. 6 minus 2x equals minus 2. I'm getting 8 is equals to 2x. I'm getting x equals 4. So then the coordinates of x comes out to be 4, comma 6. Part 1 is done. So I'm writing 4, comma 6. The point D is such that quadrilateral ABCD has AC as line of symmetry. Let me clear this. Okay. I hope you remember line of symmetry from O levels. Let me just draw a random shape. Let's say this is a parabola. What will the line of symmetry look like? It will look like this. If you have a shape like this, then the line of symmetry will look like this. So line of symmetry is basically a line that intersects the shape into two equal and overlapping paths. So then if AC is the line of symmetry, then this kind of becomes a kite, something like this. Yep, it is a kite. So uh, this would be the point D. D is such that the quadrilateral ABCD has AC as line of symmetry. So this would now extend and meet at D. Okay. So find the coordinates of D. So now you also need to know this about a kite. We had discussed all the shapes in the first lesson on coordinate geometry, and in a kite, we discussed that this is a 90-degree angle, and also this is the middle of these 2 points. Whatever these 2 points are, the point where the diagonals intersect is the midpoint of these 2 coordinates. So that means x is actually in the middle of B and D, and we should be able to find D easily. So we have D, which is 2, comma 2. Then we have the mid coordinate, which is x, which is 4, comma 6. And now we need the other extreme coordinate, which is x, comma y. So we're going to quickly use the midpoint formula. 2 plus x over 2 should be equals to 4. 2 plus y over 2 should be, 2 plus y upon 2 should be equals to 6. So we have x equals 8 minus 2, 6. And we have y equals 12 minus 2, 10. So D is coming out to be 6, comma 10. 6, comma 10. And in the last part, it's asking for the perimeter of ABCD. Okay. So what we need to do now is somehow get this length, find this length, and somehow get this length, add these 2 lengths, double it, and we'll get the perimeter of the figure because these 2 are equal, and also the other 2, these 2 are equal. So find AB, then find BC, add and double, we'll get the perimeter. Now the question is, how do we find the AC? We don't have the coordinates of A. And then how do we find BC? We do not have coordinates of B. But we do have the line AC. What's the line AC? This. So if we have the line AC, we can easily find the coordinates of A and C because we already know for A, y is 0 and for C, x is 0. So then there's nothing much left to do. So for A, we know it's x, comma 0. So if y is 0, x is just coming out to be 16. So A comes out to be 16, comma 0. And B would be for B, y is 0. Sorry, for C, not B. C is 0, comma y. So if x becomes 0, y is 8. So that gives us 0, comma 8. So now this is 16 and that is 8. Okay. Now just do 2 times length of BA plus length of BC. Okay. So 2 times square root y2 minus y1 over x2 minus x1 for A. So I'm going to do 2 minus 0 whole square plus 2 minus 16 whole square plus do the same for BC, y2 minus y1 whole square over x2 minus x1 whole square. So I'm going to do x minus 2, 8 minus 2 whole square plus 0 minus 2 whole square. So that gets me 2 times the first one comes out to be 2 square plus 14 square, that's 200 square root. And the other one comes out to be 6 square plus 4 square, that's 6 square plus 2 square, not 4 square, so 40. So that's 40. And then when I enter all of this in my calculator, 2 times square root of 200 plus square root of 40, it's giving me 40.9338 rounded to 3 significant figures. It's 40.9.